Esteemed listeners, in this tutorial we will continue with for loop but with a difference. We will discuss at length about nested for loops. Let us take an example. We are asked to make a program to make a computer to write 1 to 10 times. So writing 1 to 10 itself is a repetition. That means the computer has to write 1, then it has to check whether it has reached 10. No, it has not reached. Then it has to write 2, 3, 4 down to 10. Once it becomes 10, the index will be incremented to 11, and that will become the reason for the control to quit the for loop. Now, if you are asked to write, so that means writing 1 to 10 is a repetition. And making a computer to write 1 to 10 times is repetition of repetition. And like this we can coin the terminology for the for loops. Therefore, in this particular case, in order to meet this particular condition of making a computer to write 1 to 10 times, we need 2 for loops. The outer for loop will be monitoring whether the repetition has completed for the first time, repetition completed for the second time, third time, like this n number of times. And the inner for loop will do the repetitive exercise of writing 1 to 10. Therefore, it amounts to repetition of repetition. If we think of 3 for loops one inside the other, we can coin the terminology like it is a repetition of repeated repetition. If there are for loops, 4 for loops, I think it's pretty difficult to find out the terminology as to how we can verbally explain this kind of a repetition. But anyway, however, we are restricting our discussion to only the nesting of the for loop to a degree equal to 2. That is 2 for loops, okay, and that is 2 for loops, 1 for loop inside the other for loop. This nesting is, degree of nesting is 2. Okay, we will venture into degree of nesting equal to 3 as the need be. Particularly it occurs in computer, matrix multiplication. Till then we will hold on and we will just bother in this particular discussion as to how to make a computer to do repeated things repeatedly. So for that particular example that I quoted, that means making a computer to write 1 to 10 times, we need to write 2 for loops, something like this. Okay, for I equal to 1, I less than or equal to 10, okay, 10 times, then I plus plus. So this will essentially drive the inner for loop to work for 10 number of times. The inner for loop here we do like this: for j equal to 1, j less than or equal to 10, j plus plus. Okay, j plus plus. J plus plus. Now here we can do whatever that we want to do. Printf, we will write printf. Okay, we should not do any caption over here, as I told you in the previous discussion, because caption will also be printed so many times, which it will become clumsy. Okay, it is %d/n. Here we can write j. Let us see how exactly it works. So I is initialized to 1, so this for loop is triggered for the first time. I is initialized to 1, this for loop is triggered for the first time. It will start from 1 to 10 incrementally by 1. So this will be writing 1, 2, 3, 4, 5, 10, one below the other because we have placed slash n. Had we removed this slash n, 1, 2, 3, 4, 5, 6 up to 10 will have been written side by side. Okay, in order to have space in between that, you can just make it 4D, percentage 4D. So there will be a width of 4 spaces, and within that it will just enter 10 in the left justified fashion. Okay, in the right justified fashion. So it will write 1 over here. When it becomes 10, it will write like something like this. Okay, if you write it side by side, it will have this amount of space. So you will feel as if there is a space given between the numbers. Anyway, this is repetition for 10 times, and this 10 repetitions are repeated 10 times. Therefore, computer has to bother about at least 10 into 10, 100 times. So there is a repetition, a mammoth repetition of 100 times. We will just go through that. We will just we will continue with examples. At least we have half a dozen examples over here of different types. Okay, some of them are of technical nature, and we will get back to the regular program. Okay, this program, number 1, this program will make computer to chant 10 slogans Atmanirbhar Bharat in a stretch, that is 10 at a time, 100 times. Therefore, this is repetition, 10 repetitions 100 times. So 10 repetitions are done 100 times. Therefore, computer has to bother 1000 times. So we will include stdio.h so that printf and scanf will be working, and conio.h in order to make this clear screen and get ch to work. So we have set forth 2 integer variables I and j exclusively to take care as loop indices, and clear screen is placed, and you are going to counter a heading like hit a key to chant. So as soon as you hit any key, this will be taking that as an input, because you must be knowing by this point of time any key is a character that is given to a computer. Therefore, get ch, it's an input function, input character function, and the beauty of this get ch function is whatever that you type, whatever the key that you type, it will never be echoed on the screen. Okay, so it will be in hiding. Therefore, get ch is to be used, and we will discuss at length about this character type of functions. Okay, later on in some other point of time. Hit a key to chant, so it will wait for your any key to be hit by the user. Then the outer for loop will start. We need to chant 10 Atmanirbhar Bharat 100 times. Therefore, I equal to 1, I less than or equal to 100, I plus plus, printf stretch number 1. Okay, because this is under the ambit of the outer for loop. Okay, this printf is under the control of outer for loop. Therefore, I will be 1, stretch number 1. And this will start j equal to 1, j less than or equal to 1, and 10 j plus plus, Atmanirbhar Bharat. Okay, anyway, whenever 2 for loops are nested one inside the other, it is the innermost for loop which will be executed in first succession. When this is completed, then this will be triggering I equal to 2. Second iteration will go into force. Third iteration will go into force. And here we have placed get ch in order to have some kind of a leisure as soon as Atmanirbhar 10 times chanted. Okay, then when we hit the enter key, another 10 Atmanirbhar Bharat will be populating the screen. Okay, I repeat, this will essentially generate 100 chantings, 10 chantings at a stretch. So this will trigger every 10 iterations. 10 iterations done 100 times. Therefore, computer has to bother 100 into 10. Okay, 1000 times. And upon completing all the 100 iterative chanting of 10 Atmanirbhar Bharats, it will be finished and this will be echoed on the screen. When you hit any key, the program is going to complete. And I have not run these programs anyway, I have run elsewhere, okay, privately. Anyway, it is left to the user, okay. He or she has to type this, okay, and then see that this program will work, okay. It is suggested that you should do this, okay. This program will generate multiplication tables from 12 to 24. Okay, multiplication table also should be tackled under 2 for loops, because let us say the multiplication of table 12 of number 12 itself is a repetition. 12 ones are 12 up to 12 tens are 120. So it has to repeat 10 times. And this repetition should happen from 12 to 24. Both are inclusive. Even we should be able to see the multiplication table of 24 also. Therefore, with this in mind, we will just go through the program. Include stdio.h, conio.h, all these things are there. This is for outer for loop, this is for inner for loop. These two are meant for loop indices. Multiplication tables from 12 to 24. Okay, hit a key because it will start immediately. It will start immediately because there are 2 for loops in working. They will be working in tantrum. I equal to 12, I less than or equal to 24, I plus plus. So this will generate multiplication tables starting from 12 up to 24. And this caption will appear before any table of a particular number is printed. So multiplication table of percentage, the I will go. I is carried out, I will be brought by outer for loop, I will be 12. So in the first iteration of the outer for loop, what will appear here is multiplication table of 12. In the second iteration, multiplication table of 13, multiplication table of 14, and it will be underlined by this. So it will look something nicely, okay, on the screen. Okay, for j equal to 1, j less than or equal to 10, j plus plus. Okay, percentage 4d for a gap, of course, in order to write, okay, 12 ones are 12 twos are, okay. So here I will go, I means 12 in the first iteration, and here j means from 1 to 10. So 12 ones are 12 twos are 12 threes are, and here we have done some kind of a multiplication, I into j. I into j, 12 into 1, 12 into 2, 12 into 3, 12 into 4, something like this, something like this. So this problem is an indicator for us to explain that small calculations, small expressions can definitely be figured out in printf statements also. Otherwise, it would have called for another variable called k equal to I into j, and we must have inserted k over here, which is not required. So this is called as brevity in programming. Okay, I will come as 12, 13, 14, something like this, and j will come from 1 to 10, and here the multiple will be printed over here within this particular space. So it will appear nicely in a vertical column. Okay, it is to be executed in order to be believed. Okay, as soon as a particular table is, since say here the 1, 2, these two statements are under the control of outer for loop and also the for loop statement, for statement it is called. Okay, but this statement is under the control of this for loop, and there is only one statement under the control of the inner for loop. Therefore, we have not used flower brace. As far as outer for loop is concerned, the number of statements that are coming within the block is 1, 2, 3, 4. Therefore, flower braces are there. These 2 flower braces are a must. As soon as a particular table is printed, let us say 12, it's going to wait for you to hit the key. Once you hit the key, the multiplication table of 13 will be created, 14 will be created. At the end, finished, thank you will be printed. Okay, upon printing the multiplication table for 24. Okay, that is the thing which happens. Program 3. This program will generate an inverted number triangle 1, 2, 3, 4, 5, 6. Okay, so there are 1, 2, 3, 4, 5, 6 rows are there. 6 rows are there, and the top row should contain numbers from 1 to 6. So we need 2 for loops. The outer for loop will generate these rows. the inner for loop will print these numbers. Okay, I repeat, the outer for loop will generate these rows, the height of the triangle rather, height of the triangle in terms of rows, and the inner for loop will generate these particular numbers. Okay, therefore we will take on to this integer I, n, j. This n is meant for number of rows. It has to be given by the user. So how many rows? You question the user. He will enter say 6 or 7 or whatever. Since it is to be printed in some kind of an inverted fashion, the first row should contain all the 6 numbers. If at all there are 6 rows. If it is 7, it should end up at 7. Therefore it will start from n. So here n is 6. I equal to 6. I greater than or equal to 1, because it should end at 1. Here greater than or equal to 1, I minus minus I. It should be progressively decreasing. Okay, now j equal to 1, j less than or equal to I. So j will start from 1 and j will be less than or equal to I. In the first iteration, what I brings is n. What I brings is 6. What I brings is 7. Therefore, this will be executed 7 times or 6 times and it will be printing 1 to 7, 1 to 6. Next, it will be reduced. N will be reduced to n minus 1. Initialization is with n, and in the second iteration n will become n minus 1 because of minus I. So it will print up to 5, up to 4, something like this. Okay, now this should be carefully planned. Okay, whether the triangle is inverted or upright. If the triangle were to be upright, 1 would have come over here and it should be lesser than or equal to n, I plus plus. Then 1 will surface at the top, 1 2 will surface next row, 1 2 3, 1 2 3 4, 1 2 3 4 5, 1 2 3 4 5 6. It would have appeared like this. Okay, get ch. After printing this particular triangle, inverted triangle, it will wait for you to hit the key. Okay, then upon hitting the key, that will vanish from the screen. This program will generate a pattern something like this. Okay, these number of equal sign should be given as width and the number of rows should be given as height. Okay, number of rows. So in this case 1, 2, 3, 4, 5, 6, 7, 8 rows. 8 rows are to be given. I and j for 2 for loops and width is this much. Okay, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is the width. Okay, so number of rows you will be taking. Whatever the width of. See, by creating this thing, it is not a fashionable thing to create such a thing. And by using go to xy function, which is written in let us say C type H. Okay, I will do. Let us do those kind of problems also. You can create an interactive program where you can throw the answers in this particular box. Small kind of graphics could be done with just printfs. By creating this box is to be created by using double for loop, and within this you can enter whatever the value that you want to display. Okay, displaying a value is a different part of the program, and generating this kind of a structure is another part of the program. Okay, in that way it can be generated, and your program will be interactive, and your program will be reader friendly and also user friendly. Okay, the width is entered. Okay, now j equal to 1, j less than or equal to width, j plus plus, printf equals. So this will generate this line. Okay, this statement will generate that line. Okay, then printf /n. If you don't do this, this will get attached. Therefore, by pressing /n, okay, these two characters will be printed below this line. Okay, in order to do that, we have written /n. So I equal to 0, I equal to 1, I less than or equal to nr minus 2, because number of rows is 1, 2, 3, 4, 5, 6, 7, 8. Number of rows equal to 8, out of which 2 rows will be exclusively meant for this equal sign. Of course, the top layer and the bottom layer of this particular box. Therefore, it is nr minus 2. So within this nr minus 2, number of rows minus 2, we are going to fill up this character at the first place and this character at the last place. Okay, Therefore, now if I equal to 1, I less than or equal to n r minus 2 for those many rows, I plus plus. For j equal to 1, j less than or equal to width, j plus plus. If j equal to 1, that is the first place. If j equal to 1 and j equal to width, j equal to width, if j equal to width, if either j equal to 1 or j equal to width, printf slash, printf this hash symbol, because it should be printed only in the first column and in the last column, and in between what it has to print. If this were to be true, if it is the first column and the last column, it will print this, otherwise it is going to print empty space. Then printf slash n. So after printing this, slash n will be making the cursor to go to this particular line. Otherwise this line will also be attached over here. Okay, in order to avoid that, we have placed the slash n over here. Okay, then we will have done this much from here till here. Okay, this will be covered by the program until this point. Next, what is remaining is drawing the last border, the end border. Okay, the border at the end. J equal to 1, j less than or equal to width. Okay, j plus plus, printf equal sign. Okay, so this will, you please type. I suggest my respected viewers to type this and to see that it executes for you. Okay, this program will generate the pattern as shown: 1 1 2 1 2 3 1 2 4 5 1 2 3 4 5 6. Okay, sixth row will contain 7 numbers, starting from 1. Then after sixth row, 1 2 3 4 5 6. Okay, next 6 rows will have this kind of a shape. It will go with the decreased numbers, and here it will come. So it's an erected, it's a upright triangle followed by inverted triangle. Okay, the number of rows that we are going to read is 1 2 3 4 5 6. In the sixth row, 7 should be printed. Later on, it should print another triangle which is inverted in nature. Okay, that is the logic over here. So integer I and n, j. This is for 2 for loops. Clear screen. How many rows? You are going to ask n. Let us say if the user enters 6, it will become n plus 1, because in the sixth row you need to print up to 7. Okay, so for I equal to 1, I less than or equal to n plus 1, I plus I or I plus plus, it's one and the same, I told you. J equal to 1, j less than or equal to I. Okay, in the first iteration it is 1. In the second iteration it is 1 and 2, because I will be 2. In the third iteration I will have become 3. So 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7. So percentage 3D, this will create a space between the numbers, otherwise it will be jamming and j will be printed. So in the first iteration of outer for loop it is 1. In the second iteration it is 1 and 2. In the third iteration it is 1 and 2, 3, something like this. And this is print slash n. This is meant for creating line after line. Otherwise everything will be attached in a single line. Okay, this completes, this particular portion of the program completes the upright triangle. For the inverted triangle, we should start from n, because number of rows we have read is 6, and this should end up at 6, and progressively it should reduce. Therefore will I equal to n up to 6, I greater than or equal to 1. Okay, starting from 1 to 6, minus I. So j equal to 1, j less than or equal to I, j plus plus. So now what we are going to print is 1 2 3 4 5 6 up to 6 in the first iteration. Then I will become minus I minus 1, that is n minus 1. It will become 5. So it will print from 1 to 5. Then in the next cycle it will print from 1 to 4, 1 to 5, something like this. Okay, so you please type this and please feel that it is working for you. This program will generate prime numbers in the range specified by the lower bound and upper bound. It will also make a count of the same, how many prime numbers are generated between given two bounds. Of course, this particular algorithm is called as sieve of Eratosthenes. It is due to a king, an Egypt king. Okay, it is called as SIEVE, sieve. Sieve means the thing that is used to filter the grains. Sieve of Eratosthenes. Okay, anyway, I don't want to elaborate on this particular algorithm. Okay, but anyway, I will tell you the logic. Okay, Eratosthenes. Okay, now, right, we will just go through this. Integer I for running the for loop. Flag as a measure of checking. Okay, it's for a measure of checking. I will tell you why this flag. J for nested for loop. There is a nested for loop that is required over a lower bound of the range, upper bound of the range. N. Okay, how long it has to run. Okay, n, I think n will become redundant over here. We will remove. Of course, n is not required. We will remove this n. N is not required anyway. Okay, it becomes a redundant variable, right? If LB lesser than UB, this is a check that you need to do. User cannot give lower bound bigger than the upper bound. Okay, that kind of a chaos is avoided by admitting if and only if the lower bound is lesser than upper bound. Okay, that check you are making. If this is true, the control will enter over here. The prime numbers between %d and %d are LB, and this will create some kind of a heading, because soon after this heading what comes is a list of prime numbers between LB and UB, including LB and UB. Okay, so here we need two for loops. The outer for loop should let the numbers to go for checking. I repeat, the outer for loop will let the numbers starting from LB to UB one by one for checking, and if they are found to be prime, it should be listed. If they are not prime, it should not be listed. And if they are prime, a count is to be increased. Okay, therefore we have set forth a counter called as primes count. In the beginning there is nothing in the count of this primes count, therefore it is set to 0. We are using flag over here because, okay, I told you in the previous discussion itself, we have three kind of variables thus far. We have seen three kinds of variables thus far. One is the regular variables like I, J, LB, LOB, LB, etc. The other one is accumulators like sum, product, etc. for possible accumulation. The other kind of variables that are used in programming circles is flag. Okay, flag will always carry Boolean value. It will carry either 1 or 0. Okay, it is used whenever in any program, as a matter of fact. Number of entities, number of programming objects. Okay, here number of integers are to be checked repeatedly whether or not it is prime. Flags are a must. Okay, so I repeat, flag is a special kind of a variable which is used in any programming environment where we need to check the programming entities, programming objects, or integers or floats or whatever for some property. Okay, so this will enter. So for LB, so the outer for loop will let starting from lower boundary to upper boundary to get checked. If they are found to be prime, they will be listed. Otherwise, they will not be listed. So flag equal to 1. The first number is forced to go inside the loop for checking, and it will be assumed to be a prime number. This is a positive attitude of a programmer. Yeah, the first number that is being sent is a prime. It is as good as telling like this, flag equal to 1. Now we will put this LB. Let us say if it is 12. 12 is not a prime number. Let us say if it is 13. 13 is a prime number. Okay. This particular loop, the inner for loop, will do the only checking. It will start dividing whatever the number that is being sent by the outer for loop. Okay, that is I equal to LB, I equal to 13, I equal to 14, I equal to 15, because upper bound is maybe 24, upper bound may be 30 until 30. So in the first iteration, what comes into the inner for loop is 13 or 12 or whatever. Therefore, and it should be divided, okay, up to half of its value starting from 2. Any number that is sent by the outer for loop should be divided starting from 2 up to half of its value. Half of its value is over here, I which is brought by the outer for loop. I may be 12, I may be 13, or up to 13 by 2. Starting from 2 up to 13 by 2 as an arbitrary example, of course, j++. If in any division I mod j equal to 0, flag should become 0, because it is not a prime number. Okay, let us say the first number is 9. 9 to 25 you are testing. 9 comes over here. We assume that flag equal to 1 because it is a prime number. It's a prime number, we assume. So j equal to 2. So 9 mod j, 9 mod 2. No, it's not equal to, yeah, it's not equal to 0 because there is a remainder. Okay, now 2 becomes 3 because of j++. So 9 mod 3, it's equal to 0. Therefore flag will become equal to 0. Upon looking at break, the control will just be thrown into this particular line. Okay, the control will come from here till here, because upon looking at the break, the compiler will throw the control out of the block where break appears. So break appears in this block, therefore it will be thrown over here only to find checking with the flag. If flag, we have written if flag not equal to 0. Okay, upon checking, upon dividing, starting from 2 to half of its value, if nowhere it becomes equal to 0, then it should be prime. Then flag equal to 1, our assumption is correct. If flag is not equal to 0, the meaning of if flag means, if flag is not equal to 0, of course this should be small p, sorry. Okay, I told you C is case sensitive. Okay, if flag is not equal to 0, printf %d/i. It's only I will be printed. I has brought 13. Okay, I has brought 13. 13 is proved to be prime, therefore it is printed. Prime count ++. So prime count was set to 0, now it becomes 1 added. So there is one prime number added to the kitty of prime count. Okay, like this up to from 13 to 25, whatever the number of primes that may appear. So after 13 it should be 17, 19, 21, something like this. Okay, not even 21, 23. So whatever that is there. Okay, they will be sieved literally. Therefore sieve of Eratosthenes. Okay, so now prime count will be available only upon completion of the task. Therefore it is printed over here outside the two for loops. So here you will get as many prime numbers as is available from the lower bound to the upper bound. Printf upper bound cannot be, so this completes if block, and if the user enters the value in such a way that lower bound is greater than the upper bound, this will be flagged. Printf upper bound cannot be less than the lower bound, and the program will close. And here is some problems that is left to the user. Okay, and viewer will try this. Okay, honestly do it yourself. Write a for loop that will produce each of the sequences 6, 8, 10, 12, 66. You need to plot, you need to print this, that's all. Put a for loop, start from 6, I equal to 6, I less than or equal to 66, I less than or equal to 66, I equal to I plus 2. What to say? You should not say I plus plus. You should not say I plus plus, because 6, 8, 8, 10, something like this. And here this should start from 7. It is very similar to this. Okay, and it should end at 67. since the beginning of the iteration is known and the end of the iteration is known, for loop is the candidate. The sum of the odd numbers between 15 and 45 inclusive. For I equal to 15, I less than or equal to 45, I plus plus, I plus plus. Sum is set to 0 outside the for loop. Therefore, sum equal to sum plus I. So I equal to 15, I less than or equal to 45, I equal to I plus 2. The increment should not be I plus plus. Okay, it should be I equal to I plus 2 because 15, 17 is to be added to 15. Okay, 19 is to be added, something like this. Therefore, you will set forth sum equal to 0, and inside the for loop you would just say sum equal to sum plus I. Here this is an example of making use of the loop index itself for our computation. Apart from making the loop to execute itself, the iteration to happen, it will also participate in the calculation process, in the computation process. That is the beauty of this particular program. Okay, write a program that asks the user to enter a list of integers. The program is to determine the largest value entered and the number of times it was entered. For example, if the following series is entered, 5, 2, 13, something like this, it would output the largest value is 15 and it was entered 3 times. Okay, here I will give the clue. Anyway, okay, you kindly follow this. This is a typical example because you are not sorting. You will be taking the thing. Okay, you are going to read the first number. Okay, I will write the only skeleton part of the program. You please add flesh and blood to this and complete this. Okay, scanf. Okay, read the first number. %d ampersand num ampersand, and this is the first number. Let us say if you want to read 15 numbers, first number is out, and you are going to assume this to be big equal to num. Okay, big equal to num, you will just do that. Okay, so big num will become big. Okay, and you have to set forth number of big equal to 1 at least, because there will be one big number anyway, no doubt about it. Don't make it 1, don't make it 0, please make it 1, because it is obvious. Even if there is only 115, the number of bigs equal to 1 only. Okay, if there were to be, in this example it is 1 here, 1 there, another one. Okay, there are 3 15s, therefore that count should also come. Now I will go to the for loop. Okay, for okay, now you should start I equal to 2. Because the first number is already out. I less than or equal to n. Let us, the user must have been told as to how many numbers he has to enter. Let us say n equal to 15, n equal to, so this is a flexibility given to the user. Okay, given to the user of the I++. Okay, now what you can do here is put a flower brace, read the number, scanf, read the next number, scanf, %d num. Then soon after this, what you can do is, if big equal to num, if big equal to num, number of big equal to number of big plus 1, or you just say number of bigs equal to number of big plus plus. Now you compare. If big is less than num, that is the number that is been read, because as soon as you read this number, this will be overwritten, but big contains this number. Okay, if big is less than num, big equal to num. Okay, so when it comes for the second cycle, what big holds is this one. Okay, the recent big that has been chosen or that has been selected. Okay, here you are read. Okay, this number, this is not there. Okay, read the number, second number, let us say, compare the second number whether it is equal to this, because until this far or thus far, big equal to the first number only. Okay, if the second number is also the same number, so there is a count increased over here. If it is 2, it is not equal to this number. Okay, now comparison will happen. Big less than num, then big will become equal to num. Okay, so 5, 2, this will never be incremented. Okay, 5, 2, it will never be incremented. You try this, definitely it's going to work for you. Okay, please do that. Right. Next, the next program in the list is write a program that treats n number of integers, positives, negatives and zeros, and prints maximum integer, maximum valued integer, minimum integer and the average of the list. So for this also you need to read the first number, you assume that to be big, you assume that to be small, and go to the for loop. You start the for loop from 2 and go up to n, and just question, read it. If big is less than the number, big equal to number. Okay, if small is greater than the number, small equal to number. Okay, anyway, you take a sum also, because you need to find the average, and please declare average to be float, because average value will be definitely float. Okay, then you just make, even you can also declare sum to be float also. Okay, sum equal to sum plus the number that you are going to read. Say first number may be 13, second number may be -12, third number may be 0, fourth number may be +12, something like this. It's going to add, and some kind of accumulator will be built. It will be accrued in a number that is called as an accumulator. You divide that accumulated value by the number of entries that have been made. Okay, if it is 13 numbers, you divide it by 13. Okay, the numerator will be float, which is sum, and the denominator will be integer, and you will be getting exactly the average value. So with this, I think we have completed all kinds of problems that may occur as far as for loops are concerned. Okay, in our third tutorial in the sequence, we will discuss about threadbare, about while loop and do while loop. Then after that, we will take up all the scientific or engineering problems. Okay, are the problems, the iterative problems that are of engineering nature or technical nature. Then we will end up this particular session of dealing with iterative constructs or dealing with iterative kind of programs. Until then.